Write an equation for a rational function that has a vertical asymptote at x equals -1, double zeros at x equals 2, and the y-intercept at 0, 2. Another way of writing the y-intercept is that f of 0 equals 2. If we plugged in x equals 0 into the function, we should get 2. The vertical asymptote is x equals -1. What that means is that x minus -1 equals 0, or x plus 1 has to be a factor in the denominator. If the denominator is 0, and if there is no other factor that look the same in the numerator, then we would have the vertical asymptote. The 0 is x equal 2, and so x minus 2 has to be a factor in the numerator. But since this has double root or multiplicity of 2, we would need to have x minus 2, the quantity squared. Put all of these together, the function that we want is mostly of the form x minus 2, the quantity squared in the numerator, over x plus 1. Maybe with an unknown coefficient in the front, so we would call it a for now. By looking at this expression, we see that x equals -1 is a vertical asymptote, x equals 2 is a double zero, and then when we plug in 0 into this function, we need to get 2. F of 0 is a times 0 minus 2 squared over 0 plus 1. And this has to be 2 because the y-intercept is 2. This is now a times -2, the quantity squared is positive 4, over 1 equal 2. And so for a equal 2, what this means is that a equal 2 over 4, or 1/2. And so we would update our equation. The equation that we were looking for should be f of x equals x minus 2, the quantity squared, over 2 times x plus 1. And again, if we were to plug in 2 into the function, we would get 2 minus 2 is 0, 0 over anything is 0. So that's why we have 2 at the double zeros. And then we have the vertical asymptote because x plus 1 is in the denominator, and so the vertical asymptote is x equals -1. And lastly, we use the generic coefficient a so that we can find out what it is. Once we found a equals 1/2, or the coefficient is 1/2, we should check it. If we plug in 0, 0 minus 2 squared is positive 4. And then 0 plus 1 is 1. 1 times 2 is 2 in the denominator. 4 over 2 will give us 2. So that is the function we're looking for.